Hi everyone, this is Nehal. This video is about the dawn of a quantum revolution. What if computer could only think like nature, perfectly mimicking its deepest mysteries? For decades, the dream seems just out of reach, an idea trapped in the world of theory. But now Microsoft's team has shattered a long-standing barriers. After years of research, Microsoft team has done something groundbreaking. They took this particle that existed only in theory, observe it and learn to control it. This led to a new material. This new material can hold millions of qubits on one chip. By the way, qubit is a quantum computing building block. Mariana 1 that could change everything in a field of computing. So let's back up for a second and talk about what exactly Microsoft is announcing here. Essentially, they have introduced this fancy device they are calling Mariana 1 or something the world first quantum processing unit QPU powered by a topological qubit. It's all built around a special type of material known as topoconductor, a new word that you probably haven't heard in a everyday conversation. Topoconductors are key because they help create these exotic particles called Mariana Zero Modes (MZM). For almost a century, Mariana particles were purely theoretical, only predicted in books. But thanks to Microsoft's approach of combining a semiconductor indium arsenide with a superconductor aluminum, cooling them down near absolute zero, and then applying magnetic fields, they have managed to make these marijuana zero modes appear in nanowires on demand. Each wire end up with MZMs on its two ends, and that's building block for their qubits. But why does this even matter? Error correction is a huge deal in quantum computing because once you start having thousands or even millions of qubits, Microsoft's big claim is that topological qubit incorporate error protection right in the hardware, effectively making these qubits resistant to stray electrons, electromagnetic radiation, and all sort of environmental disruption. They knew the new measurement approach is also pretty smart. Usually, to perform quantum operation, you have to rotate qubits at every precise angle with custom analog signals. But with these topological qubits, Microsoft can just measure the quantum state through digital pulses, like switching something on and off, without needing all these complex analog controls. Microsoft is one of only two companies that have progressed to the final phase of that program. And they have signed an agreement with DARPA to build what they are calling a fault tolerant prototype. Basically, the stepping stone to full commercial system. This breakthrough is already shaking up the quantum world. AI is transforming industries faster than ever. Even from a security point of view, we have to prepare for post-quantum cryptography. Classical computers rely on transistors in silicon chip, and we had to figure out exactly the right doping concentration and all that. Similarly, quantum computing might need its own transistors movement, and it looks like Microsoft is aiming to fill that role with topo conductors. Also, it's worth mentioning that measurement based quantum computing, where you use measurement to drive computation instead of applying a bunch of rotating gates, has some real advantages. When it's come to scaling and error correction, if you think about it, having to fine tune analog signals for each individual qubit is a total nightmare if you ever want a million qubit. So what it mean for you? Here is the simple takeaway. Quantum computers like Microsoft Mariana 1 could solve giant problems, and this might change your life. Number 1, faster cure for diseases. For example, in a medicine, this thing could help doctor figure out exactly how disease work inside in your body and create medicine that fit you perfectly, faster and cheaper than ever. Imagine going to a doctor and getting a pill made just for you. Quantum computers could speed up drug discovery by simulating how molecules interact with each other in seconds instead of the years. Imagine finding a cure for cancer or Alzheimer faster, or creating personalized medicine tailored especially for your DNA. Number two, better materials for everyday life. Need a battery that charge in a minute and lasts weeks, or lightweight material for cars that never rust. Quantum computers could design these by modeling new materials atom by atom, leading to breakthrough in clean energy, electronics, and more. Number three, solving mysteries of nature. And for the natural world, it could help us understand big mysteries like why storms happen or how to clean up pollution. How do plants turn sunlight into energy? What really happening inside in a black hole? Quantum computers could simulate complex natural processes, helping us tackle climate change, invent ultra efficient solar panels, or even understand the origin of the universe. Number four, no more impossible math problems. Tasks like optimizing global shipping routes, securing data from hackers, or predicting weather decades in advance are too complex for today's computers. Quantum machines could crack these in hours, saving time and money and resources. In short, you don't need to know about how it's work, just know that it is game changer. You won't have a quantum computer at your home, but its impact could ripple into your life. For example, faster development of life-saving drugs, clean energy solution, smarter devices, unbreakable encryption, and AI breakthroughs, better products from batteries to clothing designed at the atomic level. In a few years, it is like handling scientists and inventors are superpowers, and you get to enjoy the result without ever touching a manual. How that sounds! Quantum computing isn't just about speed, it's about solving problems we once thought were unsolvable. Microsoft Majorana 1 could be a big step toward making this future real.